Number 12. So we need the bases to be the same. Now, if we could rewrite 512 as 8 to a power, that would be nice. So we could try 8 squared.
Oh, it's right here.
8 to the third is indeed 512. So that's kind of nice. So the one on the left we can rewrite as 512 is 8 to the third power. We could have rewritten it as 2 to the 6th. I think that's right. Or it'd be 2 to the 8th. Well, let's see here, 2 to the 10th. Nope. 2 to the 9th. So we could have done it with 2. Yeah, it's, yep, 2 to the third would be 2 to the 9th. But 8 works also. On the other side, to get the base to be the same, we would move the 8 from the bottom of the fraction to the top, which makes its exponent go from positive to negative. Questions on how we got to this point here? Powers of powers multiply. So we would distribute the 3. 3 times our 5x is 15x. 3 times negative 1 is negative 3. Same with our negative 1, we would distribute it. Negative 1 times negative 4 is 4. Negative 1 times negative x would be plus x. Telling us that we have 8 to the 15x minus 3 is equal to 8 to the 4 plus x. Since the bases are the same, the exponents have to be equal. Now I'm going to flip our 4 plus x around to x plus 4. It is the same thing, we just rewrote it. Now we just need to solve for x. There's different things we can do first. I'm going to subtract x first. Minus 14x minus 3 is equal to 4. Next thing we can do is add 3 to both sides. Minus 14x is equal to almost. Because 7 over 14 reduces to 1/2. So 1/2 is our answer. Questions on this here? Now again, if you do any of these here and you're not quite sure or feel like the answer doesn't seem quite right, we can always go back and check. Because 512 to the 5 times 1/2 minus 1. Then I can get a calculator and say 512 to the 5 times 1/2 minus 1. 5 to the 1/2 minus 1. And we get 11,585.2375. So we get this decimal. We can do the same thing with the other side. 1/8 to the negative 4 minus 1/2. They say parentheses. 1/8 to the negative 4 minus 1/2 is the exact same number. They give us the exact same value. So they are indeed equal when x is 1/2. So our solution for this is 1/2. Questions on this here? Any other questions on the homework? So we're going to look at the first problem of the day. 2 to the x is equal to 7. 2, if we could rewrite 7 as 2 to a power, 2 to what power would be 7? There's not a nice one. There's not an integer one. But that's the goal of what we're doing here. Now, for the first so many, we're not going to encounter this, but normally we would get whatever the base is to the exponent. So here, 2 to the x by itself. So if we had something added to it, so if it was, say, 2 to the x plus 7, we would move the 7, we would subtract whatever we needed by itself before we can do anything first. Now, I'm going to look mainly at the left-hand side first. And I'm going to apply log base 2 to our 2 to the x. We're going to worry about the 7 in a minute. I'm just looking at the left-hand side first. Now, according to our properties of logarithms, I can take that exponent and move it to the front. That's our power property. So it tells us that we have x times log base 2 of 2. And this is nice. And the reason this is nice is it's going back to one of the properties, or one of our statements that we had, which told us that log base b of b was equal to a certain value. Do y'all remember what it was? 1. Log base b of b is 1. So here, log base 2 of 2 is what?
2. 1.
1. Because the base and what's inside are the same, so it is 1. Because we can do that also in the graphing calculator. Log base 2 of 2 is 1. So it's telling us this right here is just 1. Well, what is x times 1?
X.
Yeah. So we could just say that this is just x. And really the reason we chose log base 2 was so that our log base 2 of 2 would simplify to 1, giving us our x. And it's also taken it from a problem where our variable was in the exponent, and now it's not. It's out of the exponent. That's one of the nice things with the properties of log, is we can take that variable out of the exponent, and now it's something easier to solve. Question on what we did, and why this works.
Can you choose any number?
Mm-hmm.
Oh, so you just picked 2 because it was 2.
Because our log base 2 of 2 is 1. Now, if we chose, say, 7, well, this would be log base 2 of 7. And let's see what that is. Well, that's not a nice number. That doesn't work out as well. It still would work, but it doesn't give us as nice of an answer. So we chose 2 because log base 2 of 2 is 1, leaving us with x. So questions on this here so far? But if we do it to the left-hand side, we also have to do it to the right. So we also have log base 2 of 7. Any question on how we got that x is equal to log base 2 of 7? is x by itself.
If you make it curly,
Yes. Log base of 7 is 2.80735. We're going to round to the third decimal place. So it's approximately 2.807. That's it. Now we can also use the change of base to calculate these. Our change of base stated that log base b of m is equal to log of m over log of b. So we could have also calculated this as log of 7 divided by log of 2 and gotten the same value. Log of what's inside logarithm over log of the base. And we get the exact same value. So if you don't have a graphing calculator that can do our log base, this is another way to calculate them. Questions on this first one here? Need a second? We ready for the next one? 3 to the x equals 8. So to get the x out of the exponent, we need to apply a log to it. What log would we apply to both sides?
Like log base 3 of b to 3, never mind.
Log base 3 of, well, it'd be 3x equals log base 3 of 8. Because we use log base 3 because our 3 to the x. Because our log base 3 of 3 to the x would come out front. So like I said, we have x times log base 3 of 3. Let's focus in. Is equal to log base 3 of 8. But again, our log base 3 of 3 is going to simplify to 1. So we have 1 times x, which is just x. X equals log base 3 of 8. So this really should be our approximate. But at this point, we can type it in. We can say math log base 3 of 8 is 1.89278 or 1.893. That's it. Questions on this here? Questions on anything we've done so far? We're ready for the next one. So looking at the next one here, we have our 7 to the 9x is equal to 15. What's the first thing we can do? log base 7. Because we'd use log base 7 because our log base 7 of 7 is what? 1. Because it would simplify that log base 7 of 7 to the 9x down to what? This entire side would just be 9x because our log base 7 of 7 would simplify to 1, leaving us with just our exponent. Is equal to log base 7 of 15. Questions? Is x by itself?
No.
So what do we need to do?
Divide by 9.
So we need to divide by 9, yes. And when we divide by 9, it tells us x is equal to log base 7 of 15 divided by 9. Alpha y equals enter. Log base 7 of 15 over 9 is 0.15462 or 0.155. Now the one on the left is the exact answer because that is the exact value for this here. Log base 7 of 15 over 9. The approximate answer is 0.155. Questions on this here? I'm still making the decision, but I have a feeling for the test, I'm only going to ask for that there. I'm not going to make you do the rounding, approximating, because that's less actually solving these and more just can you plug the thing into a calculator. So most likely on the test, this is as far as you're going to have to take it. You're not going to have to plug it in. If you're not sure, especially on the homework, you make sure to give me this, because even if this is not exactly what I'm looking for, and that is, I'll take that. Even if this doesn't match up with what the book's saying. The book's probably going to want you to round. I'm fine with that there. Questions on this here? It'll be sometime after next week, most likely. Let's look at the next one. 5 to the 3x plus 7 equals 311. What can we do first? Log base 5 log base 5 of 5 to the 3x plus 7 is equal to log base 5 of 311. Because again, we use log base 5 so that left-hand side simplifies nicely. Because what would log base 5 of 5 to the 3x plus 7, what would this entire side reduce to?
Or just 3x plus 7.
It would just reduce to our exponent, 3x plus 7. And the right-hand side is log base 5 of 311. Is x by itself. So what do we need to do? Minus 7 from both sides. So our 7 and negative 7 will cancel, telling us 3x is equal to log base 5 of what?
What'd you say?
311
minus 7.
minus 7. Because the 311 is contained within inside the log, the 7 is not, so it's still on the outside.
Is that?
Yes. And lastly, we would.
By that 3.
So telling us that x is equal to log base 5 of 311 minus 7 divided by 3. So that is our answer. We can plug it in and get approximately I think y'all got negative 1 or 1.145 if we type it in. Yes? Agree? Disagree? Mm-hmm. Minus 7 divided by 3. Yep. Questions on this here? We feel good about this here? Let's look at the next one. 7 to the 5x plus 3 equals 312. All right, guys, let's focus in. What would we do first? Log base 7. Because we're really wanting that right-hand side, not right-hand, left-hand side to simplify down. We want to get that variable out of the exponent. And our log base 7 of 7 to the 5x plus 3 is going to reduce to 5x plus 3. And the other side is going to become log base 7 of 312. Is x by itself. So what do we need to do?
Minus 3.
We're going to subtract 3 from both sides. Minus 5x is equal to log base 7 of 312 minus 3. Now, is x by itself. So what do we need to do? Divide both sides by 5. And when we do that, we get that x is equal to log base 7 of 312 minus 3 all over 5. And when we type it into the calculator, we get negative 0.009736.036 or approximately negative 0.01. It kind of rounds weirdly. So that's without it being rounded to a few more decimal places. So that's why it rounds kind of funny.
I'm sorry for the, like I asked this
All right, guys.
I was like, should I tell you? I didn't know.
Questions? Let's look at the next one. 36 to the 12x minus 5 equals 4,026. So what are we going to do first? of 36 to the 12x minus 5 is equal to, and again, we're going to apply log base 36 to our 4026 and go from there. Now our log base 36 of 36 to the 12x minus 5, this other side, log base 36 of 36 to the 12x minus 5 is 12x minus 5. Now the other side is still going to stay log base 36 of 4026. What would we do next?
Oh, wait, never mind. Sorry, add 5.
We'd add 5. We will divide by 12, but we're going to add 5 first. After we add 5, it'll tell us log base 36 of 4026 plus 5. And then lastly, we would divide both sides by 12, telling us that we have x is equal to log base 36 of 4026 plus 5 over 12. Why not? Yes. Yes. At any point, if you need whiteout, just let me know. Questions? Yeah. It is kind of nice how well this works.
I turned around, I was like, it's much too.
And that's why I like a lot of this stuff that we cover. It's just, it works out so well. And no matter what the setup, it will work every single time. And that's what makes this kind of nice. I mean, we could type this in to the calculator and get an answer, but again, I will take this for sure.
It was like that ever since you said that.
Let's look at this one here. Now this one here is a little bit different, not so much that the base is now e, but we have some other stuff with it. Because the e, our base with the exponent with a variable, is being multiplied by 4 and is having 7 subtracted from it. We have things with it. We need to get it by itself. So what's the first thing we can do to get this e, this base with a variable exponent by itself? If we have to, we're going to have to, we will use that, but we'll have to use it later. We've got to get that by itself.
Oh, add 7.
We have to add 7. We have to add the 7 to both sides because our negative 7 plus 7 will cancel, leaving us with 4e to the negative 0.3x is equal to 20. What will we do next? We would divide by 4 because, again, we want to get that base, in this case the e, by itself. And when we divide by 4, our 4e to the negative 0.3x is going to be e to the negative 0.3x is equal to 5. And they mainly, especially with this book, do this with e. We could do it with a number. We could have done it up to this point. But we need that base, whatever it is here, e, by itself first. Because once we get it by itself, we can apply the natural log to both sides. because our natural log of e to the negative 0.3x, or the negative 0.3x, would come out, and we're really looking at the natural log of e. And what is the natural log of e?
Just negative 0.3 of, yeah, so it would be negative 0.3x.
Because I find that is an easy way to remember that ln of e is 1. So we get negative 0.3x is equal to the natural log of 5. Get x by itself, we would divide by 0.3, negative 0.3. Telling us x is equal to the natural log of 5 divided by negative 0.3. And again, we can type those in, guys. We could type that into a calculator. Natural log's a little bit easier because the base is always e, so we can just use the ln button. It does it for us. We're going to finish it tomorrow. But we're done.